There's just a few things that I want to review with you before you start reviewing on your own in preparation for our Unit 1 statistics test. So, first example, let's revisit our old friends Connie and Oscar that were having on the assignment. These box plots represent Connie and Oscar's first semester test scores. So, first question, what is the same and what is different? So, if you notice, both Connie and Oscar have the same median score of 84. So, their median or middle score is 84. And that is the same. What is different, you can see they have different quartiles, different mins and maxes, different spread of data. So there's a lot of things that's different, even though they have the same median. So explain, why does the median not tell the whole story? Because everything else is different about their data. And for example, what's different? The min, the max, the quartiles, Q1 and Q3, the spread of data. And that spread of data we have referred to as the standard deviation. So who has a smaller standard deviation? Whose data is less spread out from the median? And that would be Connie. Connie's is a lot more consistent. She does about the same every time, and you can see that her box plot is a lot smaller. So Connie has a smaller standard deviation because she is more consistent. She does about the same every time. Does a smaller standard deviation mean that the student scored better? And not necessarily. So I'm going to put no. It doesn't mean that the student scored better. We can see that Oscar had some scores that were better than Connie. He also had some scores that were lower. So consistency doesn't mean the level of score that you get. You could consistently get Fs, you could consistently get Cs, and that doesn't mean you do better than someone if you're more consistently doing worse. So consistency just means they get about the same every time, whether that be Fs or Ds or Bs or Cs or As. So again, standard deviation does not measure how well someone does, it just measures, do they do the same thing every time? Okay, next thing I want to review is histograms. In this histogram, it shows the heights of black cherry trees. How many trees are represented in the diagram? So we look at the frequency, and we see that there's 3 trees that are between 60 and 65 feet. There's another 3 between 65 and 70. There are 8 trees between 70 and 75, 10 between 75 and 80. It looks like there's 5 between 80 and 85. And there's 2 between 85 and 90. And remember what it means, like these bins, the 3 in this first bin, they are 60 feet up to, but not including 65. In the next bin, they start at 65 and go up to, but don't include 70 and so on. So really this is like 60 to 64.999999. All right, so it goes up to that amount, but doesn't include it. All right, so how many trees? Oh, we have to add these up. So let's do that. What is that? 18 plus 7 plus 6. All right, so the frequency, it looks like there's 31 trees in that histogram. What is the bin width? The bin width is how wide one of the bars are, and for this graph it is 5 feet. What percentage of trees are 80 feet and below or shorter? So we're going to look at our graph, and I'm going to go ahead and find our 80 feet. And we're going to look at what's below that. So that's 18, 19, 20, 21, 22, 23, 24. There's 24 out of the total 31 trees, but we want percentages, so let's divide that out. So I'm going to take 24 divided by 31 and get the decimal for that. Oopsies. And that is about 77%, 77.4%, if you want to be a little bit more exact. How many trees are 80 feet and under? What percentage of trees are 80 feet and under? How many? Okay, so one is percentile, percentage, right here. But this one's saying how many? How many trees are 80 feet and under? All right, so a how many question is the percent. So that's 77%, but I'm going to change it to decimal, so point. 77. I want 77% of, in math is times, and then we want the total, and we know that there's, 31 trees total. So going to figure out how many question, you take the percent as a decimal, multiply it by the total, and that will give you about how many trees are 80 feet and under. So 0.77 times 31, and that would be about 23.87. I can round that up, I guess, to 24, so about 24 trees. And last question in this set, estimate the median height. Explain how you came or made that estimate. So the median is the middle number. So the middle number of 31 trees, what would that be? I'm going to divide 31 by 2. Okay, so the middle tree is going to be the 16th tree, right? So if there's 15 trees on one side, 15 on the other, and there's that middle one, that would add up to 31. So we need to figure out what is the 16th, or the middle number, the 16th tree. So we're just going to count. All right, so I'm going to start here. 3 plus 3 is 6. 6 plus 8 is 14. And I'm looking for the 16th tree. Oh, that's going to be in this bin right here. So we don't know the exact height. We know it's between 75 and 80 feet. So between 75 and 80 feet. We can figure out what bin it is. It's the 16th tree. So we count up until we get the 16th tree is in that bin. So we know it's between 75 and 80 feet. So there's the median. All right, example 3. Ms. Bajan polled 50 people with the following question and calculated the 5-number summary and made a box plot of the results. What percent of data is between 25 and 40 minutes? So I asked, how much time did you spend reading last night? And between 25 and 40, that's the first quartile. And remember, quartiles are named that because there's 4 quarters, like 4 quarters in a dollar. All right, so in each of these quartiles, there's 25% of the data in each quartile. And so if I ask you what percent of data is between the 25 and 40 minutes, that would be 1/4 of our data. So you'd say 25%. I could ask what percentage of data is between 40 and 50, and that's 2 of the quarters. So this would be 50% of the data is between 40 and 50. So that would be where the majority of the people are. All right, and then last example, Ms. Bajan found that the average score of last week's assignment check was 65% with a standard deviation of 3. She curved it so that if you were within 2 standard deviations, you were still passing. What is the lowest score you could get and still pass? All right, so the average or the mean score is 65. The standard deviation is 3. So I'm going to add 3 if I go to the right, subtract 3 if I go to the left. But it says if you were within 2 standard deviations, what's the lowest score? So I'm going to go this way and subtract. 65 minus 3 is 62. 62 minus 3 is 59. So this will be the lowest score that you can get that's within 2 standard deviations on the low end. So your lowest score, 59, and you'd still be passing. All right, so those are just some problems that I thought we should review that I noticed people still making mistakes on. There is a review assignment for you to do as well to practice more before your test. Make sure you check your answers and be ready for that test.